Hey everyone, how are we doing? Hope everybody did a good job on the test. I will have those graded hopefully for um, Monday and Tuesday. Probably Tuesday is what I'm looking for. We'll do a test correction day in class um, Tuesday and for cohort A, and then Thursday for cohort B, just to get those done and out of the way so you can make up any points that you may have missed. We'll go over the problems in class so you're doing them with me. We're working through them together rather than you trying to suffer through them and do them on your own to get them right so we can get them done and have that sorted out so that everybody can get the best possible grades they can get. What we're going to start working on today is linear equations. Basically the biggest part of what Algebra 1 is, algebra class here, and graphing functions and graphing lines and sorting through everything. So what we're going to do is we're going to kind of go back and start from the basics. Today's lesson is going to be on the coordinate plane, and then graphing some stuff from tables and things like we had done a little bit in the last unit. We're going to kind of get into that more here because we're definitely going to be getting into the point where we're going to be graphing lines pretty much as often as we can in algebra. So let's get going. First off, I want you to think about, what do you know about the coordinate grid? Can you identify the x and y axis? Can you identify all the four quadrants that we have? And then what are the relationships and what are the ratios that the quadrants have with each other, with the points? Where are things going? There's really no way to enter the answers for this into Edpuzzle. I just kind of want you to think it over in your head. Do you remember where the quadrants are? Do you remember where the origin is? Is there anything else you know about the coordinate grid and what we have to have doing as we go through it? And kind of think that through. I'm going to give it a pause for you, or you want to pause the video, you kind of think about it if you want to. Just kind of think about it, see if you have a good understanding of what the coordinate grid looks like. Okay, so here's the coordinate grid. I kind of have arrows pointing to the different parts of the grid. You can see the origins in the middle where the x and y axis cross. That point is 0, 0 when we're talking about the xy values. Then the quadrants, the x-axis is the horizontal axis. The y value is the vertical axis. We have to remember that the x value, when we kind of talk about functions and stuff as we get going, is the x values and the x-axis are going to be what we eventually start calling the domains of our functions. Whoops. Pen's not working. Pen's really not working today. Sorry. So the x-axis becomes the domain of our functions, in that all the possible values of x are included as the domain. And then the same thing, the y values are the range, where all the possible values for y end up in the range of where the answers can be. So that's what we're looking at there. And then the quadrants go counterclockwise. Quadrant 1's top right, then it goes 2 to the left, 3 down from the left, and then 4 is underneath quadrant 1. Okay, so again, what do we know? All points of the coordinate plane have a value for an x and a value for y, written as in parentheses x comma y. The big part of what we're going to do as we're plugging in and getting function answers, the x is going to be our input into the function, the y is going to be what kicks out as the other part of our point. Does that make sense to everyone? Also, the x and y graph, coordinates, axis, whatever you want to call it, they extend both directions into positive and negative infinity. I don't have it graphed here and pictured here, but you can picture the axes with arrows on the end of them. They go on forever. We can end up with a point that's positive infinity, negative infinity for the x and y values. And it's plotted way out in God knows where. Each quadrant has a relationship between the x and y value. Quadrant 1, both values are positive. Quadrant 2, the x value is going to be negative. The y value is positive because we're on the left side of the origin, the left side of 0. You want to talk about it and think of it. The other quadrant, quadrant 3, both the values are negative. And then in quadrant 4, they flip and the x is positive and the y is negative because now we're on the right side of origin and the south side of origin. And then points that fall on either the X or Y axis, they're not considered in a quadrant. So you may be asked and kind of identify coordinate points and what quadrant they're in. You have to remember this relationship, that if it's negative, positive, it's in quadrant 2. If it's positive, negative, it's in quadrant 4. If it's negative, negative, it's in quadrant 3. Then obviously if it's positive, positive, we're in quadrant 1. Whoops, too far, I think. Sorry about that. Okay, let me just make sure I'm in the right spot. Yeah, okay, I'm good. Sorry. My God, I've gone too far. All right, so like I said, we're going to have to be able to identify which points we are in a quadrant. So here are 8 points. I want you to enter your answers in Edpuzzle, which quadrant you think these points fall into. Then come back and check your work, and we'll see how everybody does. Okay, we should have gotten these for answers. Point 1 was in quadrant 1. Point 2 is in quadrant 2. Point 3 is in no quadrant. It's on the x-axis. When 0 is the y value, we're on the x-axis. Quadrant 3 for problem 4. Quadrant 2, number 5. 6 is in quadrant 4. 7 is in no quadrant. When 0 is the x value, then we're on the y-axis. And then quadrant 4 for the last one. Hope everybody gets this right. So that's one part of what we need to do. What we're also going to be doing is graphing functions. We did this a little bit last unit briefly. We're going to get into it more in depth now as we kind of go forward from here. Different ways to graph functions and lines and things. So there are steps to do it. If you have, there are a bunch of steps to do it different ways. What we're going to work right now is graphing them with a table. So what I want you to do is you make a table of values of x. We're going to pick x values that are practical to graph. When we're graphing functions and stuff, we're really going to have limited space on the graph paper that we have, on the coordinate grids I kind of put on the pages that you can do work on. They're going to have limited space, so you want to pick practical values. You're not going to pick 100 and 200 to plug in for x. You're going to pick, what I obviously recommend is picking from like -2, 1, -1, 0, 1, and 2 is the best way to do it. You get in the habit of doing that, then next year, or in 2 years, when you're in Algebra 2 stuff and you start graphing quadratic functions, those are the values you're going to use all the time, just because that's kind of what it always kind of works out to be. Then you're going to calculate an output for each x value. So I plug in -2 into my function, it's going to kick out a value for y. That's the y column on the table. And then you're just going to plot the points. As we're working now, we're just plotting the points because they're functions. We're plugging in values for x, we're kicking out values for y. As we get forward along into this unit, there's going to be different rules we're going to do to graph some stuff that will give us, rather than just points, it'll give us lines. So we're going to graph the following function. We have y equals 2x minus 1. Again, like I said, I've picked -2, -1, 0, 1, and 2 as my values for x that I'm plugging in. It's just easier for me. It focuses in the middle of the graph. So we're close to the middle. We should have enough space to graph what we need to graph. So when I plug in my values, I plug -2 in for x, I get -2 times 2 is -5, minus 1 is -5, sorry, 4. The -1 times -2 is -1. -2 minus 1 is -3. Then I get -1, -1, and -3. So those are the values that I'm going to plug in, and now I'm going to plot those points. Whoops, wrong way. So here are the points coming in to plot and graph where we are. That's my first point, -2, -5. Then I get -1, -3, 0, -1, 1, -1, 1, 1, and then 2, 3. So as you look, you kind of see a trend. We're moving slightly up. We're slanted up from left to right. We always read graphs from left to right. And we're going through that way. It makes sense to everyone, pretty easy to do. I know it's pretty simple. We're just starting with the basics. Okay, so your turn. What I'm going to have you do is just give me the values that you'd have to plot. Hopefully you're able to plot them somehow. Just kind of sketch a graph out to make it look like you graphed them pretty well. What I'm going to try to do going forward is have the notes to you beforehand. So, you know, again, I would have picked -2, -1, 0, 1, and 2. Here are the points graphed. Again, it's a straight line through the middle of the graph, slightly more steep than the one we showed as an example. Okay. There are other ways we can graph data. You may be given real data to graph, so we're not going to actually plug in values for X. We're just given a table of data. Some sort of observation in the world over years or time or something, and kicks out some data. So the big thing with this here is you have to make sure sometimes the data is going to be bigger than the space you have, so you have to make a scale and you have to kind of think through how we're going to graph it to make it look somewhat reasonable as you do it, to make it understandable. So we have this example. In 1920, the ratification of the 19th Amendment to the U.S. Constitution gave women the right to vote. The table shows the number of votes per year to the nearest million for the 3 elections before 1920, the 1920 election, and then 3 elections after 1920. So we're basically looking from 1908 to 1932, those elections, and the number of votes. So to graph this, you have to kind of pick a scale, because if I look at my chart, I think my coordinates are from like -19 to +19 on both the X and Y axis, and I have a values of 40. So what I'm actually going to do is I'm going to make each one of my lines worth 2. So rather than going 1, 2, 3, I'm going to go 2, 4, 6, 8 as I count my graph. And then I just start graphing the points. Here are the points coming in. You see that I go over -12, so I've gone over 6 lines. That's where my -12 value is. I've gone up to where the 15 would be, which is going to be between 2 points. And that's what the graph would look like. Does that make sense to everyone, having to figure out the scale? I mean, obviously we want to have it perfectly where we don't have to have a scale, but sometimes that's going to make the graph paper have to be so big that it's not going to be feasible to do it. So you're going to have to sort through on this table stuff. What's the scale? There'll be definitely stuff we'll work on later on too as well, that we'll definitely have to show it. And you want to try to keep the scale the same on the X and Y axis. Sometimes you can't, but you have to remember and think through what you're doing. I didn't label these points, but sometimes you want to label the lines so you remember what the numbers are. All right, so your turn. Again, try on a piece of paper to graph it out, make sure it kind of looks reasonable to what you did. Again, it's another election result, this time from 1972, when they first allowed 18-year-olds to vote. And it shows the difference in the number of votes with 18-year-olds voting. Okay, again, this is what your chart should look like. Here was a little more difficult. I actually did 2 things on this one. I made my lines, my x-axis, everything's worth 1, is what I did on my scale. So it's 1, 2, 3 from left and the right. So my first point goes over 12 points to that first dot. But then what I did is I actually started my scale at the first line on the y-axis, so up from the origin. I made that the 69 line and then just kind of went 2 from there. So every line is worth 2 from there to give me some sort of scope of what this looks like. If I was able to kind of go out and make the graph look like it should, it gets to be really, really big and unwieldy and just doesn't make sense. So I scaled it down quite a bit. We will be working on some graphing stuff too that'll help us do some other homework as we kind of go through this. Okay. That's the end of the video. What I want you to do now is there's a lesson out. It's a thing out on Desmos. So there's a link in Google Classroom to it. I want you to go do that, sign in with your Google account. It should have you linked to a classroom. It's kind of a game of what they call mini marble golf. It's trying to get a bunch of marbles into cups by plotting points for line segments. So it's just practice of kind of figuring out how the coordinate grids work, where you need to put the points, how to do that. I just want to give everybody practice for that. There's also going to be homework out on edgeelastic.com. I know we use it for tests, but I'm going to try to start using it for some homework assignments too, to track things better and easier that way. What I'm going to do on those though is I'm going to kind of leave them open for multiple attempts. So you can go through and do it once, and if you didn't like your score, you can go back and try it again. It should give you the results of how you did, what you got right and wrong. That way, I won't actually be giving you feedback on them, but you can see, oh, I only got 20%, so I want to try it again because I didn't do that well. And I want to try to make sure that everybody's doing that to get to be the best that they can be at it, and just get better at the math. And it helps me track stuff so I can be a little bit more on top of what we're doing. So if you have any questions, send me an email. Otherwise, have a good weekend, and I will see you all on Monday.